In the previous session, Cyndi showed you how to install the Kubernetes-based OSM distribution, the community version. And now we are going to see how you can monitor all the elements of OSM and the Kubernetes cluster itself. So for this purpose, we have used something called a Prometheus Operator, okay? First of all, before you start, this is a hands-on session, so a disclaimer here. If you go to the public documentation of OSM, you can see that you can install the the monitoring part of in the Kubernetes installation with the option Cage Monitor, okay? But please, for this session, do not do this, okay? Because what we are going to do is work based on the latest candidate release of OSM. So the dashboard have been remodeled and it's more easy to navigate through the dashboards, okay? But what you will see here is what's the health of the Kubernetes cluster, how are the OSM components are, these are up, down, how are the CPU, memory, disk, and this information that are very useful in the day-to-day basis. So how we are going to do this? So using the same virtual machine that Cyndi provides to all of you, okay, we're going to do the following. So first, let's install the monitoring part of the distribution, and then I'm going to explain how this works. Okay, so I'm inside the virtual machine where OSM was installed in the previous session. Okay, so if I go here and I get all -n OSM, I can see that OSM was installed here. Here are all the pods and the services and so on. Okay. So what we're going to do now is download from the OSM repository, okay, the DevOps repo, okay. In the previous session, Gianpietro shared with you the link of the presentation, so you can have the same instructions for you to try, okay. We are in the slide number 28. So we clone the repo, the DevOps repo. Okay. We enter into the repo. You can see here all the information that is downloaded, that has been downloaded. Okay. We use the latest candidate dashboard for the monitoring part. Okay. Now, as you can see, all this information have been updated. Okay. And then we use the global installer script for installing the monitoring part. Okay. So I'm going to do this in advance, and now I'm going back to the slide so we can I can explain a little bit how this is expected to work. Okay. So again, as you can see here, the monitoring part is installed as an additional element expected to be installed after the installation of OSM, okay, using the -c cage option, okay. If you have any question, please do not hesitate to ask, okay. Thank you, Gianpietro, for sharing the slides. Okay, so let me close here. So what is going to do this installer? So this installer is going to install the Prometheus operator. Okay, this Prometheus operator installs different elements, the Prometheus database, some exporters to get information from the OSM pods, some node exporters to get information from the node itself, and this information will be added to a Grafana dashboard. Okay, where will be configured a data source that will be this Prometheus database. So in a nutshell, this Prometheus operator will be consuming information from the Kubernetes cluster, okay? How the pods, the parts of the Kubernetes like kubelet or the API server and so on, how the OSM pods, like let's say how the pods for RO, MON, LCM and so on are behaving. And we have special exporters, very well known, like Kafka, Mongo, and MySQL for getting specific information from these elements, okay? And besides that, we'll retrieve information from the host itself. Okay. So this monitoring information is already available in the deployment of OSM, the Kubernetes-based deployment of the US OSM. Okay. There is a similar feature for the Docker Swarm deployment. Okay, that will be explained in more detail tomorrow by Gianpietro. Okay. This monitoring is the main objective of this deployment is to monitor the OSM infrastructure, not the VNF or NS. It's expected to is in one Grafana dashboard or some Grafana dashboard in the same Grafana element, okay, to be present the information from Prometheus operator and from the information that MON retrieves from the NS and BNS. Okay, this feature is expected to be available in the next point release. Okay, as I told before, okay, besides the Prometheus operator, some Prometheus porters are installed. So if we go back to our virtual machine, okay, these have finished. Okay, by default, this set of pods are deployed in the monitoring namespace. So if we go kubectl get all -n monitoring, okay, we can see that a set of pods have been deployed from the monitoring part. As I said before, we have a Grafana installed, okay, some Node exporters for MongoDB, Kafka, the Node exporter, and MySQL exporter, a Prometheus database, and the Prometheus operator itself. Okay. So what we're going to check is the Grafana part of let's say the end result of the whole monitoring part. The exported retrieved information from the elements of OSM are stored in the Prometheus database, and then in Grafana we will be able to see all this information in some dashboards. Okay. So this is what I was saying. Okay, we have the Prometheus operator part. Okay, the operator. Well, what you are seeing here is the operator creates some custom resources. Okay, so we are able to create on demand specific elements that this operator recognize and is able to create on demand some elements to the monitoring part. For example, if I want to create a new service monitor, I just need to create a new element via Kubernetes. So dynamically, a new object will be created, and then the Prometheus operator will recognize this new object and have to it knows how to do with this new object. So a new service object will be created, and then the Prometheus part will be scrap the information from the adapters that export through an endpoint the information that is retrieved from each pod. Okay, and then what we are going to do in this hands-on session is to customize how we see the information that we have retrieved. Okay, so okay. So once we have finished the installation, okay, The Grafana dashboard will be available in the port 3001. Okay, so if we go to the IP address that we have and the port 3001, okay, if we go just a second. This is my IP address, port, sorry, port. Okay, I'm able to access the GUI of Grafana. Okay, the default user and password are let me check here. The default user and password are admin, and the password is prom-operator. Okay, so I can copy and paste. Okay, so what we are going to see here in the main GUI. Okay, the information, this dashboard has been grouped in two main folders. The Kubernetes cluster, where all the dashboard from the Kubernetes information, the cluster itself is shown, and the open source MANO folder, where the information regarding the OSM itself components are shown. For example, as you can see here, in the Kubernetes cluster, we can see the information, let's say, about the pods, how are behaving the pods. So, for example, if I want to see how LCM is doing, okay, we can see the CPU usage, okay, the CPU quota, the memory usage, and so on. Okay, let's say if you want to know, okay, this is a more detailed information. Okay, this is regarding a more profound information about this specific pod. Okay, we can see here, for example, memory, CPU, network input and output, and how many times in the last time have you restarted this pod.
Yeah, sorry, okay. Alexis, where I see the name of the pod?
You can see it here.
Okay, here I select it. Okay,
yeah,
that's fine.
You can select here the namespace, let's say OSM, and now
yes.
I want to see, let's say LCM,
yes.
same as before. So you can you can see it here.
Okay, that's fine. It works well in my lab.
Perfect. That's good news. Okay, let's continue. Okay, this is the information regarding the Kubernetes cluster. Okay, but if you want to see how your OSM system is behaving in a more short manner, in a more concise manner, okay, we can see here, for example, a summary at how is doing OSM right now. So in a very short and concise dashboard, you can see that all the pods are up and running, okay, and how much CPU are they using. Okay, this is, let's say, a summary, very short and very specific, just about each element of OSM. Okay. Now, if you want to see how, let's say, Kafka is doing, okay, just the same. This is, as I told you before, you can have, let's say, regular information about the pod, or more specific information about one element. This element, for example, a Kafka, besides the information about the CPU or memory, maybe you're interested about how Kafka is doing regarding the characteristics of Kafka. You want to see how, let's say, the message stored, or message consumed, and the petitions per topic, and so on. So let's say, and this information is here thanks to the exporter that we added to the system, the Kafka exporter. Okay, this is the function, the main reason that the Kafka exporter is here. So the Kafka exporter knows how to attack the Kafka element of OSM retrieves the information, and then Prometheus is able to get the information from this exporter, and then Grafana gets that information and shows that information in this dashboard. Okay. And then we have information about the host itself. Okay, the host where versus MANO is deployed. You have a summary here. Okay, how is the CPU? Okay, the swap is not available. So we were checking the information that is shown in Grafana. Okay, we said that we have two main folders: the information regarding the Kubernetes cluster and the information regarding OSM, the host and some elements, and very concise summary on how OSM is doing. Okay, this is the summary. Let me put it here. Okay. Again, this is the host part that we were watching right now, just here. Okay, we were watching the CPU information, the RAM information, and this is the host itself where the cluster is deployed. Okay, and this is the information regarding the CPU, disk, okay, memory, and the working part. Okay, as you can see, it's very concise information. Enough detail to see how it's doing the host, but not too much that you're overwhelmed by all the graphs and so on. So let's do some hands-on. Okay. Okay, this is what we were watching. Okay, the Kafka, MongoDB, and MySQL specific metrics. Okay. Here are some commands. Okay, specific commands. If you want to see, this is the one that we did before. Okay, this is the one that shows all the pods, services, and deployments and stateful sets are deployed when you install the monitoring part. Okay, you can see the config maps that were created during the installation. Why these config maps are important? Because I told you before, the addition, for example, of a new dashboard or a new Prometheus data source or service monitor, okay, are done via config maps. This is the example that we will do later. Okay, so this is just information that you can try. Okay, so let's play a little. Okay, so what we're going to do is shut down the MBI element of OSM. Okay, so in the summary dashboard, we will see that MBI is set to 0. As you can see here, it's not that let's say showy. Okay, you can see here that there is no MBI running, but it can be discarded by default because, let's say, it's not read or it doesn't say error or something like that. Okay, so what we're going to do is play a little bit with this dashboard and see how easy it is to modify them and to customize them so you are more comfortable with them. So first of all, we are going to shut down the MBI. We do this part. Okay, so if we return to the dashboard and go to the summary, okay, well done.
So guys, just
discard. Okay, so as you can see the summary, you see now that there is no MBI pod running right now, but what we're going to do is customize this dashboard so you can see an error when something is not behaving as expected.
Alex, a small note. Like when I scaled it down, the dashboard updated automatically. I need to do a refresh to get it.
At least in my case, the dashboard is configured to be refreshed every 30 seconds. In my case, I didn't have to refresh it.
Oh, okay, I see. Okay, so like you configured. I think I don't have. Yeah, it's the same for me. Okay, like 30 seconds. Okay.
Okay, okay, great.
Perfect.
So if we see the information about the MBI element, okay, get all -n OSM, we see that we don't have any MBI, okay. So let's play a little with this dashboard. If we follow the instructions, okay, what we say here is, okay, let's modify a little bit this dashboard. Let's make it more showy. Let's modify it. Okay, so if we go to this graph, okay, here in the top of it, you see an option to edit the graph. Okay, you go to edit. Okay, you have three options here: queries, visualization, and general. You go to visualization, okay, and you see in real time a preview the how this information will be shown. So for example, in this test, we propose to activate the coloring part and activate the graph, the gauge shown, okay. We were here, we said that we activate the coloring part in the value, and we delete the gauge part of the graph. We activate the coloring part, we deactivate the gauge, and then we set some mapping values. Okay, for null value we set to error. Okay, for 0 we set to error, and for 1 we set to OK. Right. Okay. Error. Okay. 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 So as you can see here, you can see the error. Okay. I did an enter here, so maybe it is refreshed here. I'm not sure if it resets itself automatically, as I said before. Okay, so I go back this button. Okay, this button. As you can see here now, you can see quickly where is the error, because it's more it's more easy to see. Okay, so but what's the problem here? If you reload this page, okay, leave page, this information is not stored, it's not saved. So next time will be the same. Okay, you said, okay, this is not very useful, but what we are going to show you is very easy, very quick, how to make these changes permanent. Okay, so we go again, edit, visualization, coloring of gauge, values, add value, error, oops, sorry, 0, error, 1, error. Okay, we go back, and then we go to the button save dashboard. Okay, we save the dashboard and save the JSON to file. Okay, we save the file. Okay, and that's it. Now I'm using Firefox, so if Control and J, I can see my downloads. I go to explore my downloads. Okay, I will open it with code, VS Code. Okay. This is opening. So this is the information that I have downloaded from the modified dashboard. Okay. We download the dashboard that is used, the monitoring part is using. Okay, we downloaded it to our computer. Okay. I copy this dashboard to my local computer. Okay, to my local to my computer. Sorry, OSM for you. No. OSM for you. Okay, I have locally the file. Okay, that is here, summary. Okay, and as simple as this. This is the magic behind the automatic creation of dashboard. As you can see here, there is a label that is called Grafana dashboard. So each time you create a config map with the label Grafana dashboard equal to 1, okay, this sidecar of the Grafana chart will be exploring these components and check if this component fits the expected format, and will update automatically the information of the dashboard. So we delete the previous information, we don't want anymore this information, and we copy the new one. So we copy the new one, we paste it, okay, we save it. Okay, now our config map has the new information. Okay, so if we go back, yes, we'll upload again the information. To the virtual machine. OSM for you. Okay. So where this information is stored is right here in DevOps installers Kate. As we see, this has been modified just right now. Okay, right now. This is the summary dashboard that we have updated, and then we just apply this config map. As simple as that. We go to apply. Oh, careful here. This is not a dash. This is not a dash. Maybe there's something wrong. So my line 28. Maybe I copy and paste wrongly. YAML to JSON. Sorry. Yeah, but one quick thing. I made this mistake one more time. Please be aware that make the proper indentation here. This needs to be on a different level of the name of the file. So this is very important. Please be aware of that. So I will override the file. Okay, OSM for you. Yes. Okay. Now, okay, the file has been updated, and then I apply it, and this has been applied. So if I reload the dashboard, the change that I have done before will be there. Okay, update, leave page. As you can see, you see now the graph the same as you have modified before. Okay, and that's it. These new dashboards, as I said before, will be available in the next point release. It will be available maybe in some weeks ahead. Okay. If you were able to successfully install, that's it for the presentation, for the hands-on. Okay. Thank you very much.
Thanks, Alexis, for the session. Now, the next one, before starting to instantiate something in your setups, I would like to make a quick review of packages in OSM. Because packages are the elements that contain all the modeled information of the network function or network service, which is a set of network functions. So anything you want to instantiate or automate in OSM needs a package. So in NFV, there are basically two types of packages: the VNF package, or virtual network function package, which contains all the characteristics of the network function. It's modeled in the package. So there is a descriptor following standards that describes how the network function needs to look like. So orchestrators would take that information and go to the beams, SDN controllers, automation platforms, Kubernetes clusters, whatever it needs to implement that network function and configure that network function so it's ready to provide a service. So again, it's not it's not a matter of just instantiating some virtual machines and that's all. That's not the value of OSM or any NFV orchestrator. It's a whole set of things that would let you operate a network function and have it ready and have it configured. It's true that we, in the Hackfest sessions, start with instantiation of VMs, but then we keep adding more things. At the end of the week, you have network functions with actually operated, and that's how we have designed this Hackfest as well, having that into account. So back to what is a package in NFV. A VNF package is the element that is delivered by the vendor of the network function, containing the images or reference to images that it needs, the descriptor that specifies the compute resources, all the connections it needs between its components, and the connections it will expose to other components that will consume the services, any performance requirement, any metric that needs to be monitored, scaling descriptors, how to scale this function, automation scripts, maybe more complex software for operating the network function, and anything that this virtual appliance, let's say, needs to be operated. So it can be as the product of this VNF can be as small as a single Docker container or a single virtual machine with a base image that is already configured, or it can be as complex as a set of dozens of virtual machines and containers that interoperate between each other, and when you launch them, they are pre-configured so that they provide a service already. So the main element of a VNF package is a VNF descriptor, which has most of the details it needs. As I said before, it is built and provided by the vendor or the developer, the manufacturer of the network function. And well, VNF is just a term where we used to use, but now we are kind of moving to a more generic term, which is a network function, because we also have physical network functions. I mean, from NFV orchestrator, we are able to go to a physical network function and eventually configure it, because the network service needs some configuration, and that the life cycle of that configuration specifically matches the life cycle of the virtualized network function. So it makes sense to own some of the configurations as some physical network functions. We have containerized network functions. We have Kubernetes-based network functions, which might be the same. We have hybrid network packages or functions, sorry, that mix many of these network functions types in a single package. For example, you may have a network function that has a VDU and a KDU, or if we are deploying a Kubernetes deployment unit, for example, inside the same VNF. So at the end, operators get this package from vendors, and they can feed the orchestrator with this package so they can eventually use it for a network service. So the network service is the second type of a package. It contains the description, basically the descriptor of the VNFs that build the network service. So it contains references to the VNFs or the network functions it needs, contains a description on how these elements are connected between each other. It can contain as well some scripting or software for operating the network service as a whole, because you might need some configurations that make sense for the network service, because you might need to go and grab the IP address of a VNF that provides a high performance database and feed it to an element, a network virtual appliance that needs to access this high performance database. So that's and configure that database so that it's used by the network appliance. So that's the kind of configuration that makes sense for a network service as a whole and not for a specific network function. So it's not included in the primitives or in the automation scripts or operations for a single network function by an operator, by a vendor, sorry, but the operator of the network might need to add some automation to the network service as a whole. So it is built by the operator from VNFs that conform the service that they want to build, to fit to the catalog. And this is what at the end is launched, a network service. So again, network service is just a set of VNFs that together with some extra artifacts like specific how these VNFs are linked or automation scripts build out a service that is part of the NFV catalog. These descriptors are modeled based on standards. In particular, in OSM, we are starting to align to the SOL 6 standard of ETSI, which models the descriptors in YANG. So everything that you need, that you can put in a descriptor of a VNF or a network service, it's at the information model of OSM. And all the components of OSM refer to that information model so that their implementation is easier and development is much easier. And whatever you can put in a descriptor is here. So if you are looking for references on if any feature is available to be modeled in a descriptor, a good reference is to see the model first. For example, if you want to see how Kubernetes-based deployment units are modeled, this would be the equivalent to a set of pods that build a deployment unit in a VNF. Here is the model. You can run primitives. You can use specify how the KVU is deployed through Helm charts, through UU bundles. You can specify a Kubernetes cluster that it uses. If you want to see how scaling groups are modeled, so you have a scaling group descriptor in a VNFB, and they have these options there. And you also have navigable versions of the models so that you can get some tooltips as well on each of the attributes of the model. Okay, so it's very useful to have a reference to the model on which descriptors are based in OSM. At the end, we have the network service package, which, as I said before, is the one actually being launched as an instance in OSM. So the instance is the network service. And when you launch a network service, you're launching a set of VNFs or a single VNF, it depends on what you want to achieve. So it requires constituent VNF packages to be present in the system first. So you need to make the VNFs available in the catalog, at the local catalog first, to then make the network service package available, because the network service won't be, you won't be able to make the network service part of the catalog if the VNFs are not there already. So this particular example, which is the one we are going to use in the first exercise of instantiation, is a very simple one. That's why it's called Hackfest Basic. It's called Hackfest Basic NS. It needs the VNF called Hackfest Basic VNF. So it needs it to be present. you see constituent VNF, this VNFD ID reference Hackfest basic VNF. So it will look for this one, and it is putting a member VNF index of 1. This can be a string, that it can be anything, any text. And then we have the VLD part, which is the virtual link descriptor. And as you know, in YAML, these dashes are lists, right? Are elements of a list. So how many VLDs we have? We have 1, because we have just 1 dash. And that virtual link is described to be a management net, is to be called management net, is said to be a management network. I mean, to be considered by OSM to be a management network. So whenever OSM is looking for a management network to configure a VNF through charms, for example, it will use the network that is marked as management network true. Then we have the connection points, which are, sorry, the actual interfaces.
Going to Bank of America. I'm going to.
Sorry, there's some noise there in the back. We have these connection point references that refer to connection points that are interfaces, let's say, that are exposed by the VNFs, by the constituents VNFs. So in the management network, we are putting the VNF called Hackfest basic VNF, which has this index reference 1, and the specific port of the VNF that is connecting to this network is this one, VNF-CP0. So these 2 elements must be present at the VNF descriptor for it to work. If we want to connect another VNF to this this same network service, we would put a second constituent VNF, and we would put a second connection point in the same network, for example. Or if we want to connect a second port of the same VNF in this network service, then we just put an additional connection point to the same VLD. Okay, so this is the network service, a basic example of a network service descriptor, and then a VNF descriptor might look like this. This is, again, a basic example that says this is the VNF called Hackfest basic VNF. Okay, this is the one that the network service is looking for. It has 1 VDU. How can I tell it has 1 VDU? Because under VDU, it just has 1 dash, that is 1 element of a list. So just 1 VDU. That requires an image called Ubuntu 1604, no? Image Ubuntu 1604, and a flavor with 1 CPU, 1 gig of memory, and 10 gigs of storage here, VM flavor. It exposes an interface, it has just 1 interface, interface, just 1 dash, so just 1 interface. It's called VDU at 0. It's of external type, that is, it's supposed to be connected to a network service or to an element that is external to a VNF. It's not supposed to be connected to an element that is internal to the VNF. We talk about internal connection points when we have more than 1 VDU in the same VNF, so that we can interconnect those the VDUs between each other. We will see more of that tomorrow. It has 1 virtual interface of type Paravirt. We can put here SROV, pass-through, or other values that make sense to identify how the VM is going to be connected to the network. And it has the external connection point reference called VNF-CP0. So this is a name that I'm using in the network service descriptor to refer to the connection point that will be connected to any given virtual link or network. Okay, so what else? In this virtual link of the network service descriptor, we are not referring to any existing VM network. It will create this network if I instantiate this as it is. If we want to connect to existing network, we will have to specify so with a parameter called VM network name. But we will see more on this tomorrow. So this is how VNF descriptors connect with network service descriptors and what will be instantiated. At the end, you have your packages. You can upload these packages through the dashboard, or you can upload them through the CLI. And once you have your VNF packages and your network service packages, you can launch only the network service package. No, the VNF will be used by the network service package. And with this icon here, and you will see more parameters there, like specifying the bean and other things that you will see in the hands-on session. So now the last part of this hack is instantiating your first basic network service. For that, I will leave you with Cyndi Alarcon again.
Okay, thank you, Gianpietro. Well, so I'm gonna share my screen. Okay, so in this hands-on, we're going to integrate a bean, an OpenStack bean, and we're going to instantiating a basic network service. So you have to enter to your virtual machine where OSM was deployed. Okay. So we have to execute this command using the OSM client. Also, we can do this. We can integrate our OpenStack bean using the user interface. But this time we'll start using the OSM CLI. So first we have to indicate the OSM command, then we have to indicate the bean create. We have to indicate the name of our bean. In this case, we're gonna use OpenStack site Hackfest, and will be replaced with your number of your tenant. We'll add the user and password you have for access to this tenant, and we'll indicate the IP of the bean, that is this one. So you have to replace that in your command. And we have to indicate also that tenant name with a number of your tenant. We have to indicate an account type that is OpenStack. If we go to the documentation, we can see that we can integrate OSM with different beans. You can see we can integrate with OpenStack, VMware, Amazon, Microsoft. So this time we're gonna use OpenStack. And we're adding a config, a special config, just to tell OSM that all the VMs that are deployed by OSM use this security group default configured in the OpenStack platform. So if you execute this command, you should execute this command, then OSM bean list. There should be a bean created. And if you want to check the more information about this bean, you have to run OSM bean show OpenStack site Hackfest and the number of your tenant. The status of this bean integration should be enabled. Also, you can go to your user interface and check that information too. Here I have some steps to create the bean integration using the user interface. It's like the same parameter we used before, and we'll have the same result that the bean integration is enabled. And so I'm going to create that Vim integration. I'm gonna list, and I'm gonna show. So it says it's enabled. So okay, very good here. We can use the user interface to check that information too. If we want to add new Vim, we can add it the same way we did. So this was the first part of this hands-on that is integrating a Vim. So I see that most of you have integrated the OpenStack Vim with OSM platform. So now the last hands-on is launching your first network service. So in this session, we're going to upload the VNF NS package to OSM and create our first network service. So here we have the information of the package we're going to use. This will we use a virtual instance based on Ubuntu 16.04 with a flavor of 1 CPU, 1 GB of RAM, and 10 GB of disk, using video ETH0 like as interface. And that will be connected to VNF CPO. So this is the information of the VNF descriptor. Okay, and we have here the network service descriptor that we use the VNF that I showed you before, and will be exposed to a network created in the Vim, in OpenStack Vim. So here we have also like YAML information that we have to upload to the OSM platform. So first, what we have to do is to download this package from OSM site. So here I have the two packages, the VNF package and the NS package that have all its own descriptors. So the second step is to upload to the OSM platform. So we use the command OSM VNFD create and OSM NSD create, and we select the package to each kind of component. So if we want to list, just execute the VNFD list. We see that the VNF package has been created in OSM. We do the same for the network service descriptor.
Just note that you can use the dashboard for this as well. If you have, for example, your packages are downloaded to your laptop, your computer, you can use the dashboard and upload them just by dragging and dropping the tar file in the NS packages or VNF packages section that Cyndi is showing. You just drag and drop there. That's another method you can use. Also, you can find instructions in the user guide to installing the OSM client in another separate system, so that you can upload or manage packages from there. In that case, you will have to add an environment variable that specifies where is the API of OSM located, because it will be remotely. Okay, but for now we are just using the local OSM client and using a local interaction with the API. So OSM client is local, and using the commands in there for you to get familiar with them. I think it's better that way in a Hackfest, because you will find more options when using the OSM CLI than when using the dashboard. In dashboard, you will have a little bit more limitations when interacting with OSM. But of course, it follows the OSM client. So when we first develop a user a command for interacting with OSM as client, we do it in the CLI first, and then when it's okay, then we add it to the dashboard.
So now we have upload the package. So now we're going to create a SSH key in order to send our public key of our virtual machine and to have access to the instance that we'll be creating from OSM. Okay, so right now we're going to create a network service in OSM. We can do that using the UI or by the OSM client. So here I have to replace some information. Here I'm indicating the name of the network service, the name of the network service descriptor. I'm indicating the name of the Bing account that is related to my tenant number. I indicated also if I want to use a SSH key to access to this environment. I indicating my public key, and also I adding special configuration related with the virtual link descriptor. I configured this component with a name GMGNet, and I indicating that we're going to use the network OSM X that is available in the OpenStack bin. So I run this command, and we have to see now if this network service was created with NS list. So right now you can see that network service state is in building, in the operation is instantiating. That means that it is creating the virtual machine in the bin, the OpenStack bin. So if you go to your project, you will see a new virtual machine that is from your network service that you have created recently. So let's check again the state. So now you can check the network service state is ready. you can check this information to using the UI. So you go to instance and network service instance. Okay, and here we see the network service instance we created, and we see that is running. So the other step is to access to this instance. So for this reason, we created a public SSH key. So we're going to access from our OSM VM to this instance created. Okay, I have to put the IP address. The IP address is this. And as you can see, I have access to this instance that was created by OSM platform. So as you can see, we have launched our first network service. Now we can delete this element from OSM, and the instance created in OpenStack will be deleted too. So I'm gonna exit the VM. Okay, I execute the deletion of Hackfest 1 network service. I go to my user interface, and the network service is deleted. So to explore the information of this network service package and VNF package, we can use the user interface. For example, if we want to see the configuration or the YAML information, we can go to this button, edit, and check that information. We can also update this information if we want to make a modification. For example, in the VNF package, we describe the characteristic or the features of the VNF. So here we indicate, for example, the name of the image. This image has to be created on the VIN, in this case on the OpenStack. Also, we can change the values of the flavor. We can change this online here in this part and update with a new information. And then instantiate a new network service. Here, we add a name, we add a description, we select the network service descriptor, the VIN account. If we want to use access with a SSH key, we can indicate it here. And if we want to add a specific configuration, we can use this part too. So there is a bonus hands-on, just like a homework for you. Here we are creating a VNF descriptor from the OSM client. Here we don't download anything, so what I have to do is to delete the package that I download to not get confused. Okay. And we'll create this package using the OSM CLI. Okay, we want to follow these commands. Then we're gonna build the package in order to create the tar file. We're going to upload this package, the NFD and VNFD and the network service descriptor to OSM like we did before. And we're going to create a network service, but you're going to have an error like this. So the challenge or the homework here is to find the error and solve and fix it. So one clue is compare the information, the yarns of the VNF descriptor that you are using in this exercise and that we were using in the exercise before. Make some updates of the configuration and try it again.